next speaker is Randy Gigante. Randy is a long-term space activist with 30 years experience in building satellites and providing communication services to commercial and government customers, including the Navy, Marines, and the airports. He has served on the board of the National Space Society and is currently representing the National Space Society on the board of the Alliance for Space Development. Hi, Randy, how are you?
Great, can you hear me?
Wait, yep, can hear you really good, and I'm so sorry about that earlier.
I'm here to work in wherever you can here.
Thank you so much. The screen is yours.
All right, can you see my screen?
Yep, looks perfect. Thank you.
Okay, so I've been trying to update what we're going to discuss here based on what we've heard today. Quite a bit of information, particularly from Peter Garrettson, and I know you're going to hear a lot from John Mankins tomorrow about some of the more futuristic, more current stuff. But we've talked a lot about public-private partnerships in particular, and just wanted to highlight before we get to the details. The National Space Society has a public-private partnership COTS type program paper out as of a year ago on our website, and one of the many things that's on our website that we're going to be talking about shortly here. So thank you for inviting me today, and on behalf of Michelle Hanlon, who is the president currently of NSS, and also of For All Mankind, I want to express my appreciation for the foundation for joining the Alliance for Space Development, which was founded by both National Space Society and the Space Frontier Foundation. The Alliance works with Congress and the administration to fund space development and settlement and to embed these goals in the law of the land. I serve on the NSS Policy Committee, which is headed by Jeremy Wainscott. Jeremy also previously served as president of the Alliance, so there's a close relationship between the two groups. I got involved with solar power satellites many years ago when I was first in business school. I was getting my MBA in Philadelphia and working with several space organizations, including Gerard O'Neill's organization, the Space Studies Institute, based in nearby Princeton. I worked with SSI on fundraising and also participated in several of their conferences on space manufacturing, even did a poster paper on solar power satellites, surprisingly enough. As a chemical engineer, though, by training, I was most attracted to the potential for building structures in space from lunar materials. At that time, finding water on the moon at the Institute was considered the holy grail. If you got that, everything was possible. And now here we know water is abundant on the moon, and we are planning to go to the lunar South Pole with people to understand just best how to extract it and how much really there is there. So with regard to space solar power, today's theme, the National Space Society, as you see from this paper, has been at the forefront of supporting this clean energy technology for decades. Let's see here, screen. I'm going to try to use everything just from our website. The whole idea here is to see the tools that are available here for you to access to make your interest in space solar power a little more useful. We've been supporting this clean energy technology for decades and continue to work hard to ensure that members of Congress and the executive branch understand the potential of space solar power. And whichever nation harnesses this technology first will not only have a huge lead in energy distribution, but can share the technology with nations all across the globe. Again, imagine the huge advances we can make. You've heard already today, clean power, a pristine environment, and energy pouring into the most impoverished parts of the world. The benefits are almost beyond imagining. Unlike ground-based solar panels, space power will be unaffected by weather. Unlike nuclear power, there are no dangerous byproducts. And unlike the burning of fossil fuels, space solar power is kind to our environment. The theme you'll see in what we're about to show here. Other presenters, like I said, John Mankins will discuss some of the latest information. What I'd like to focus on for the next few minutes is why we are doing this in the first place. Constantly have these discussions with friends and colleagues and family members, and it's really hard to get beyond the concepts of, is this a death ray? How is this possible? How can you do such large things in space? So we really have to have tools to break through that barrier first and foremost. So we've developed at the National Space Society a short video tool, 3 minutes long, but can be broken down for various applications, which we use to talk to congressional staffers, investors, and environmental groups on the importance of space solar power. Fabio or Mike, if you could show the video now, we'd appreciate it.
Fabio, that's the video. Thank you.
Dear Earth, we're sorry for all the things we've done to you. We're sorry for coal plants, oil spills, nuclear waste, dirty factories, auto emissions, wildfires, and climate change. We really didn't understand. We didn't mean to hurt you, but our needs got the best of us. Now we know there's a better way, one that will give us everything we need without harming you ever again. Can we start over? We have a new plan, and we really mean it this time. We promise. It's all about electricity. We know, we've tried that before. Coal, oil, gas. Those were the choices for a different time. But we promise to do better because we have a new source of power at our fingertips. Space solar power. The sun provides clean and virtually limitless power 24 hours a day. It is a huge, inexhaustible source of energy that will be kind to you, Mother Earth. The ways we currently harness solar power are a great start, but only provide energy for part of the day and are limited by weather and other conditions here on Earth. And your atmosphere, while we cherish it, reflects about a third of the sun's energy back into space. Solar power generated in space and sent back to Earth frees us from these limitations and will allow us to provide virtually unlimited amounts of energy to the entire planet, night and day. Space solar power is clean, abundant, and the costs of collecting and transmitting it back to you, dear Earth, are negligible. And space solar power is virtually emissions-free and kind to you. We have the rockets and the proven technology we need to start building space solar power now. We may even be able to utilize the resources of your neighbor, the Moon, to build these orbiting power stations. We really want to do the right thing, Mother Earth. We're ready if you are. Space solar power will help us to repair the climate and make you healthier than ever. So what do you say, Earth? Ready to give us a second chance? Space solar power is the answer. To learn more and donate, go to go.nss.org/SSP.
Okay, so
Thank
that's
you.
Again, it's just a tool, but it's a very effective tool from what I've seen so far. We've done a lot of just tests with different groups. Certainly with younger people, it has a much better effect than with people of our generation. But it is a very effective tool to get. The key is just to get the interest, and it's right on our webpage here, the course Space Solar Power. But that's just the first hook. The question then is what do you do when you've got someone's attention? And so what we created, I think, was talked about earlier today, was the Space Solar Power Library on the National Space Society website. Let's see here. So if you get basically all the research from back to the 70s, you can see we go back way back to earlier than this is the original studies in the 70s as well. But I'm going to highlight just 3 of the many different papers here, just as 3 good examples, because I think it illustrates how you can use this database for your own needs. The first is a solar power satellite built of Lunar Materials. You see it right down here at the bottom. And let's see here. So basically, I have a hard copy in my, let's see here if we can show it here. One of the first papers I got back in 1985 was this was commissioned by the Space Studies Institute, and it really still is topical today in terms of exactly what some of the questions we've seen in chat. The primary conclusion at the time was it was possible to design a solar power satellite with 99% lunar materials using existing technologies in 1985. and reduced the cost by 98.7% from the previous Earth baseline. And that was something that was one of the core beliefs of the Institute for decades, because it was something that was really hard to get across to the average person. So radiators for heat dissipation, and particularly heat pipes, were a clear focal point in the study, as we've talked about today, the heat dissipation. I believe one of the things I looked at just today is like a huge, cooling is like 90% of the weight of the mass in the original study. But it didn't mean it couldn't be done, because most of that could come from lunar materials. The second document I would like to highlight is also on this list right in front of you here, is Towards an Early Profitable Power Sat Part 2, which takes advantage of the massive reduction in launch costs via the Falcon Heavy. Let's see here. There we go. You can see that. Okay. So close this up. There we go. So one of the keys there is that it's not just the microwaves that can be used to beam this energy back to the Earth. You can also use fiber lasers that also help you solve some of those, again, those thermal problems. It's still hypothetical, but the key advantage there is that you could actually get a demonstration plant up there about 6 megawatts of power using existing off-the-shelf types of technologies. And you could do that with just a single Falcon Heavy launch. And this is when the Falcon Heavy hadn't even launched yet. So it was certainly very much ahead of its time. But it's something, again, that's in this database that you can go back to to see what was happening just 10 years ago. And finally, most recent document, I think, is, let's see here, if I can go back to that. That's all from the producer standpoint. From the user standpoint, that's really what you'll hear more. You've heard some today, and you'll hear more tomorrow. This is from the Naval Research Labs. This to me, a very good document, because it was comprehensive in terms of how much detail it provided about where we were in terms of state of the art. It's called Opportunities and Challenges for Space Solar for Remote Installations. It states that there are no fundamental breakthroughs required to implement even large-scale solar deployments, and it goes through a detailed analysis of the technology readiness of each level of the technologies. And specifically, the lowest level of readiness is not the thermal radiation. It's more the experience of building these huge structures in space, primarily, and also the actual demonstration of power beaming. So the power, on a scale of technology readiness of 1 to 9, again, these are at a level of 5. Here you go. So this is typically, just to give you an example of the details gone into it. And this is actually a document that's been used to brief members of Congress, this and its successors, to say, look, this is how much has been done, and this is how mature the technology is. Again, something to refer back to when you're looking at the latest technology. I chose these papers, again, as an example of what someone interested in space solar power should review before proceeding with their own activities, whether it be developing new space policy or designing new ways to build large structures in space. I've talked to many people over the past few years. No matter what their hard level of understanding, whether they're a casual space enthusiast or a hardcore engineer, they find it easier to believe in building large space habitats than building large solar power satellites beaming unlimited power to the Earth. When you read just a small portion of this research, you realize that space solar power is not just a dream. It is a core technology whose application is critical to solving both our problems on Earth and our ability to expand into space. So what can you do to help with this vision? Besides, of course, joining the National Space Society, you can advocate with the congressperson and senators to expand the existing research being done, currently now only by the Department of Defense. And even that is very, as we've heard today, in very low levels. What NSS advocates, again, is a test module in Earth orbit providing actual power to a remote location on the ground. The cost of this would be roughly in the $500 million range, spent over several years. It's a small number in the overall budget, whether it be NASA or the Department of Defense, but it certainly would be leaps and bounds beyond what we spent so far. Space solar power is a concept whose time has come, but the US is still just taking small steps to embrace it. We need to take much bigger ones soon to realize its potential. And so I ask you to come join NSS or one of the members of the Alliance, like the Foundation for the Future, and realize the vision of a hopeful human future. that this is based on. Thank you.
Randy, thank you so much. I really want to reiterate that the National Space Society has been at the forefront of this idea for literal decades. I mean, just let that sink in for a second. They took a pretty unusual position back 30 years ago in their support of this idea, and you wouldn't have had the resources of Coyote, Garretson, and Quast had not the National Space Society provided a beachhead for them to do the work that they had to do. So really, truly, hats off to the National Space Society. They've been a literal and figurative pioneer in this field for a really long time. So for those are the folks that are with the NSS on this call internal to the chat. I'm glad that y'all are here, but really this is a message to the folks on YouTube and Facebook that are watching this channel that had not heard this organization. It's a solid powerhouse in the community and an asset. So thanks, Randy. I'm going to turn this back over to Leo to do some of the Q&A, but just from my own heartfelt thanks, I just want to let you know, thanks a lot for the NSS. And, thanks for Michelle for pointing you our direction on this one. Thank you.
Thank you so much, Randy. I have a question. Space is the next civilization. We as humans must go out into space to continue to break barriers and evolve. But as we continue the acceleration of space access for everyone, we must also combat the climate crisis here on Earth. What are some of the biggest uncertainties we have to overcome to make the momentum of space-based solar power a reality?
That's a question for me?
Yes.
So as we mentioned in the video shows, it's really about getting people to believe in it. It's just amazing. You can show all the numbers in the world to someone and they still don't believe it until you're actually going to do it. Any more than they believe Musk could land 2 rockets on reusable rockets until they saw it. It's just, we have to do it, and that's what we've been trying to fight as Peter Garretson and others have been fighting for years, trying to convince everyone that this is feasible. It's not a scientific problem. It's an engineering problem, and we have some of the best engineers in the world. We don't have enough of them, but we do have very smart engineers that could pull this off very quickly if this became a general understanding that this was what we needed to solve the climate crisis, and mainly to create a hopeful human future where there's unlimited growth rather than limits to growth.
That's actually very true. Lieutenant General Quast earlier stated in his panel that there are many men and women who can advance the technology of power, transportation, and communication to accelerate space-based solar power to solve our climate crisis. In your opinion or your thoughts, how can the commercial sector help to advance these technologies?
The commercial sector is, again, looking to make a profit. So that's the question is there the case to invest in it today? And talking to even people of the faithful, venture capitalists, and even leaders of the National Space Society said, would I invest my money today in a solar power satellite, my own personal money? Probably not, because I just don't see the return on investment. But do I think it's really critical to do? Yes. So that's been the constant hurdle is we all know this has to be done, but we don't see how to make a profit of it if we're investing our own money today. We need to have some of the technical risk reduced. I think there's less technical risk personally than people believe. I built solar power solar power arrays for communication satellites for years, and just expanding them is what I see this as. It's a natural expansion. The beaming part, it's been proven that the Japanese have proven it, other people have proven it. It's a question of the degree, not whether it works or not. It's how efficient is it? And certainly it's going to work in space, and we just have to do it, and we have to believe that we have to believe our own numbers. We can't just say, well, the numbers work, but I just can't start it. But again, it's the first. That's that first solar power satellite. I guess fundamentally it's because originally in the original studies, because of the limits of physics, you could not go below a certain size. And I think that's what hampered us for decades, is because we believe we couldn't make a small one and the big one was too expensive. We really needed to make a small one 20 years ago.
True.
Just to prove it worked.
Yeah, what do you think are some solutions for driving down the cost and getting space-based solar power panels into space?
I hope companies like Made in Space or Redwire, they're going to show us how to do it with more quickly. But the most of it previously was the launch costs, and then of course for me again the holy grail is Lunar Materials. Taking a mine to a refined product, that is certainly a big step in terms of creating that kind of infrastructure in space. So I do agree that the first one should be built from materials from the Earth, but we should be very quickly getting ready to build them from materials coming from space. And that requires more companies getting involved in the cislunar infrastructure and reducing the risk of using those lunar materials while using those lunar materials for other applications, whether it be energy or just radiation shielding, whatever you need to get that first market. But the real market is to supply solar power satellites from the moon.
Okay, and we have actually Tim Chrisman, who is currently in Akron, Ohio, leveraging opportunities of a new space economy. For those who are watching to learn a little bit about the NSS, what would the economic impact be to small towns like Akron based on a new space economy with the help of the National Space Society?
Well, I hope that we'll be getting a lot more people interested in the potential for green energy and whether it be building rectennas on. I mean, I did most of my career was building the receiving stations for communications. So building those relatively simple structures for creating a huge amount of power for their local communities, to me, that's something that anyone could do at any location on the planet to learn how to do those types of things. And but again, ultimately, it's unlimited energy allows you to do a lot of things that you wouldn't consider today, because energy is finite.
Yeah, I really loved the video that you showed us. I thought it was captivating, and it was one of those things where it's like it's inspiring, but also it shows the urgency and just how critical it is to get the momentum and the acceleration of space-based solar power. And I loved what you said, that something like that resonates a lot with like the younger generation. Can you talk a little bit of how space activism changed in the last 30 years, and what are some key beliefs or perspectives that you learned early on in your career that are more prevalent as space access for everyone continues to accelerate?
That's good. Space activism is certainly we've had we have, it's called March Storm every year. We have a lot of people of our age group in the 50-60 range, and we have a lot of people that are students coming out of college. So it's quite an interesting dichotomy to see the different perspectives. And again, it's unfortunate to see that the interest level and political activism has gone down over the past five or 10 years. And I don't think it's just related to the previous president, but it is related to the different perspectives of the generations. But I'm really encouraged that with this type of a theme of melding saving the planet with expanding humanity beyond the planet, that we can find something that resonates with all generations. And I think that this does, if we communicate it in this type of a way, rather than getting tied up in the engineering and technical details of which rocket and what the thrust is and things like that.
Yes, very much so. I mean, we're trying to, here at Foundation for the Future, we're doing our workforce program. So we're trying to go, like Lila said earlier, from K to orbit. We want to start educating and inspiring, kids as early as kindergarten level on to pretty much get them prepared and give them all the skills and education and everything that they need in order to succeed, in order to make this space access much more available and prevalent as generations to come, but starting now, because it is a huge crisis, like with our climate, and space-based solar power is incredibly just urgent to have to get that started, as soon as possible. And with the help of all of these corporations and companies, and being here in this conversation is the start for a lot of people. So I think we're almost out of time. I just wanted to say, Randy, thank you so much for being here with us, for your amazing presentation, and for being a part of the conversations for the future. So if you can, just go ahead and put in your LinkedIn information on the chat to continue networking, so people can see where to find you, and more information on the National Space Society. And for everyone listening, thank you for joining us for this Conversations for the Future, powered by Foundation for the Future. Conversations for the Future is a nonpartisan event about near-Earth space infrastructure from now to 2035. Foundation for the Future is dedicated to the creation of a public-private partnership for space infrastructure development. To support this cause, or to sponsor one of our events, please visit our website at www.f4f.space. That's the number 4. And we are grateful for the support of our corporate and individual partners.